this normal review worksheet. So remember, the key thing to keep in mind with normal is that there's really 3 types of problems. There's 4. 1, the basic normal CDF, right, from lower bound to upper bound. This is that's when they ask you to find the probability. So when they say find the probability, it's generally normal, lower bound, upper bound. 2, find K given probability. So you're told the probability of K being less than 5 is 0.3. So you're given the probability like 0.3, 30%, whatever. They want you to find what K is. So that's the second time. So for that, we use invert normal. Right, we have to have the area and stuff like that. And then third one is if you're missing the mean or the standard deviation, or if they're mean, both of them. That's sigma, that's the wrong one. Whoops. This one we need to find, you got to use the z equals invert normal of the area. You got to find left hand side if you have a basic calculator, or you tell what tail it is if you have a fancy calculator, with 0, 1. Remember, z is always 0, 1. That's a standard normal. So that's like that. So those are generally the 3 main types of normal questions. I pause there. It could be 4. Sometimes they want you to find the area to like you have to understand the area of a normal curve. It looks like this, and all that to 1. So sometimes it'll be like, oh, we'll give you left side to point something, or right side to point something. You have to know that, okay, to find the missing side, it's 1 minus those guys. That's kind of like a fourth way of doing it. But in general, these are the 3 main ones. And I guess fourth would be just understand how to work the curve, right? It's all area 1, less than this, greater than that. If you want to find any missing, you always subtract it from 1. So those are general ideas. So let's do this worksheet. A random variable x is distributed normally with a mean of 45 and a standard deviation of 20. Again, notice how with normal problems, they have to tell you it's normal. So, oh, okay, it's a normal problem. Here's the mean, here's the standard deviation. Okay, we have those things going for us. Find the probability that x is less than 4. So this wants to find the probability. So it's a normal way. We're going to do normal CDF. I like to draw it to know what I'm talking about. So here's my normal curve. The mean is 450. And we want to be less than 475. So 475 would be further than 450. And you want less than, so you want anything below this. Something like that. So all we're going to do here is, I want to find that. So I'm going to go from negative infinity, which we don't have, so we do negative E99, to 475. So negative E99, 475, mean, standard deviation. So we're going to plug that all into our calculator. So second distribution, normal CDF, negative E99 to 475, mean is 450, and standard deviation is 20. So you get 0.89435. Remember, 36 fixed, so 0.894. So there we go. B, given that the probability that x is greater than a is 0.27, find a. So again, they're giving us probability, so it's going to be an invert normal problem. You do want to draw it so you kind of know what's going on. It's greater than a is 275. So remember, when you see that is a bad line, like that. Come on, there we go. When you see greater than, that means start on the right hand side. So start like this side, and then go 27% back from that. So this is 50%. So 27% back. So like around here. Doesn't have to be perfect, but you don't want, if you're on this side, you're doing it bad. If you're right next to the middle, you're doing it wrong. Right? I tend to be 27%. So that's 0.27, and this will be my A. So I gotta find A. Now this is the thing where I said if you have a fancy calculator, you can do invert normal. You can put 0.275. This will be mean, and it'll be standard deviation. Again, it's not a z, so we put the actual mean and standard deviation. You only put 0, 1 if it's a z thing. If you have a fancy calculator, you put 0.275 and just say you're in the right tail. All the rest of us had to go, okay, it only does left tail. So I had to go 1 minus 0.27. So I get 0.73. So that's what I got to plug into here, since I have a normal calculator. So we're going to go invert normal, second distribution, invert normal, 0.73, Again, I have the mean standard deviation, so I just use them for 50 and 20. So 3 sig figs, 462. So there we go. Again, does that make sense? Well, the mean is 450, so yeah, 462 would be the right of that. So the next one. Oh, these are all problems from old IB exams. A multiple choice test consists of 10 questions. Each question has 5 answers. Only one of the answers is correct. For each question, Joe randomly chooses one of the 5 answers. So first things first. What do you notice is not there? They don't say normal anywhere. Right? It doesn't mention normal at all. So this is not a normal problem. The fact that it's multiple choice test consists of 10 questions. Each question has 5 answers. Means this is, or 10 questions, this is a binomial question. If you're not sure there, that's fine because you might not be sure there. Here, find the expected number, find the probability that exactly 30 questions correctly, find probability more than 3 questions correctly. That should be the dead giveaway to binomial question. Exactly, more than, less than, binomial. So what do we need for binomial? We need a couple of things, right? We need M, P, and R. Now, generally N and P are the same for everything, and R changes depending on what question you're doing. So what's our N? Well, we're doing 10 questions. So that's our N. We're doing 10 questions. Each question has 5 answers, and only one answer is correct. For each question, Joe randomly chooses. So a lot of people get the probability wrong here. There's 5 answers. That's on my N. That's the probability. You have 5 questions. You're going to randomly choose one of them to be right. What's the odds of getting it right? Well, only 1 out of 5. That's my P. Right? If there's only 5 answers, choices, and only one correct answer, and you're going to randomly guess, you have a 1 in 5 shot. There we go, 1 in 5 shot. So that's what my P is. So my number is 10, my probability is 1 over 5. First question, find the expected number of questions Joe answers correctly. Expected number, remember, all that means is mean. It means the exact same thing as mean. And that's in your formula sheet. Expected value normal for binomial, it says N times P. So to find the mean or the expected value, it's just N times P. So here will be 10 times 1/5. I could do that. 2. So expected value using it correct is 2. 2 out of 10 questions, just by randomly guessing. Find probably that Jose answers exactly 3 questions correctly. So remember, exactly is binomial PDF. So B will be binomial PDF. N is 10. Probability is 1/5, and R is 3. So we need our calculator back. We're going to go second distribution. Binomial is toward the bottom. Doing PDF because it's exactly. And we plug our stuff in. Trials is 10. Probability is 1/5, 0.2 if you want. And then we want exactly 3. Hit enter. Again, 3 sig figs, 0.01. 2.01. So about 20% chance. There's a 20% chance to get 3 correct. Exactly 3 correct. C. Find probability that Jose answers more than 3 questions correct. So again, more than 3, no, hey, write it. It's that. It's not greater than or equal to, it's not less than or equal to, it's greater than only. More than. So C is this. Right, so we're going to use binomial CDF, but what's wrong here? It's pointing in the wrong direction. Right, it has to be less than. When you do CDF, it has to be less than or equal to. So remember the way we fix it, since it's pointing in the wrong direction, there's only one way we fix it, you do 1 minus. So when you flip it, very important, right? This does not have a line underneath it. So when you flip it, you get the line underneath it, in this case. A lot of times you can do the opposite. A lot of times they give us one with a line. When we flip it, we don't have a line. In this case, the opposite. We have this. We want the complement of that, which would be a closed circle going that way. Hey, that's what we want. So we don't do anything else. We have to plug into our calculator. We're going to plug in 1 minus binomial CDF of x is less than 3 into our calculator. So bring that back out. Again, I like typing that all in so I don't forget. So many people just give me this part of the answer. I'm like, oh, you forgot to subtract it from 1. So I always put them all together. 1 minus binomial CDF. Everything else is the same. 10, 1 out of 5, and 3. And I get 0.121 if I'm doing 3 sig figs. 0.121. It's about 12% chance he gets more than 3. 12% chance he gets more than 3 correct. Let's move on. So this one, the score of a test is given to students that are normally true with a mean of 21. So right there, we know it's a normal distribution problem because they tell us, hey, this is a normal distribution. Unlike the last one where it didn't say anything. And we have the mean, and we have the standard. Oh, we don't. 80% of students have a score less than 23.7. Find the standard deviation. So we're missing the standard deviation. So we got to find that. So remember, anytime we have to find that, we have to use this formula. The standard normal. So, big part of that is understanding what this is. 80% students score less than 23.7. So you have to know how to rewrite that. So probability that you scored less than 23.7. There's somewhere else where I have a little more space. So I should have switched these. Let me switch these real quick. Since I'm missing something, I'm going to use this. So let's talk about how to rewrite this guy right here. So probability that you scored less than 23.7 is equal to 0.8. That's what that means. That's very important when we do A here. So when we do A, right, when you use this formula, type in what you know. I have my mean. My mean is 21, so that's this guy. I have my x. My x is 23.7. I don't have my standard deviation. I leave it alone. And we always find z the same way. You're never given z, you got to find it. Z is always the same thing. It is invert normal with the area and then 0, 1, whatever your area happens to be. In this case, we're less than 23.7 is 80%. So if you want to draw it, remember less than starts on the left side, right? So we're on the left side, we're going to go 80%. So here's 50% to middle. So we're going to go past the middle. So like all the way to here-ish. That's 0.8. And that's what we're looking for. That'll be my whatever. So we're looking for that guy right there, right? So 0.8 is over there. So if you're doing the fancy calculator, make sure you say left tail. For all of us, that's the default. So we're happy with that one. So we're going to plug that into our calculator. Sub that on into our calculator. So in this case, it's going to be second distribution, invert normal, 0.8. See, by default, the default's always 0, 1. And I get 0.84162. Now I'll probably only write 3 or 4 sig figs here because it's not the final answer, so I'm not going to round it yet. So I'm going to get 0.84162. You know, I write that. I'm going to still use all these values on my calculator. Equals 23.7 minus 21 all over phi. With that, let me just do the math there. 23.7 minus 21 is 2.7. So I'll just rewrite it like that. And then I got to solve for my my standard deviation. So I'll multiply by standard deviation and divide by this. Easiest way to do it. Multiply by this. So then you get, I mean, if I show all the work, I'd be something like this. You don't have to show all the work. I'm doing it because I'm teaching it. So that equals, and then put that in my calculator, 2.7 divided by my answer here. I get 3.20809. Remember 3 sig figs? So 3.21 is what we want. And now that I have that answer, I cancel the rest of this. A student is chosen at random. The student has the same probability of having a score less than 25.4 as having a score greater than 25, greater than B. Find probability the student has scored less than 25.4. Okay. So, if you look at this again, so the student has chosen, let's review that because I read that badly. I thought it was going to be a different question. The student chose at random. The student has the same probability of having a score less than 25.4 as having a score greater than B. So look what they're saying. So we have our chart here. Our mean was 23.7. So what they're saying is this person has this person has the same probability of having a score less than 25.4. So 25.4 is over here. As having a score greater than B. So there's So if you look at this thing, right, that's more than 50%. So of having a score greater than the B. So like there's gonna be a B over here somewhere that's had the same score, the same percentage just on this side. Like there's gonna be a B on this side. So what they're trying to say is that the area from here to here should match the area from here to here. Right? Scoring less than 25.4 is the same probability as scoring more than B. That's all they're trying to say. Okay, so let's do the first question first though. Find the probability that a student scored less than 25.4. That part's easy. I'm gonna actually do it up here. Right? Find the probability. So we're just doing a normal CDF. They want to score less than 25.4. So here's my 24, but whatever. 25.4. So you just want to be less than that. So that's going to be normal CDF from here to there. That's all it is. From negative EV99 to 25.4. Let's put that in our calculator real quick. Right, so second distribution, normal CDF. Right, I'm going to score less than 25.4, so I'll go negative 1 E99, perfect, to 25.4. The mean is 23 point, no it's not, what's the mean? 23.7. No, it's not 21, man. This is wrong. 21, there we go. So again, the mean is 21, I read that wrong, the mean's right here, 21. Sorry about that. So 21, and then the standard deviation, we just found it, 3.21. Hit enter, and we get 0.91536 figs. So 0.915. So again, I'm getting all this right here. 0.915. Okay. So how do we find this one? Well, so now it says find the value B. Now there's actually two ways to do this. If this is 0.915 and from here to here is 0.915, they're kind of the same distance away from the origin. So you could just do this. Remember, it's a normal curve. This is symmetrical. You could just figure out what this is. How far is it from 25.4 to 21? Which is like 4.4. And then subtract it backwards here. So again, the normal curve is a symmetrical graph. If I know this is equal to this side, then I just find the symmetry there. So minus 4.4, 21 minus 4.4 would be 16.6. So that should be my answer. If you want to do another way, there's version way 2, alt way. What do we know? If I draw this curve here, where this is 21, I have some B here, where the possibility getting greater than B is 91.15. We just figured it out right now. All that is 0.915. So I could do inverse normal, and I have to do the left side, so I should have to do 0.85, 0.085, right? Because I have to do the left side. So 0.085. Mean is 21. Standard deviation is 3.21. If I put that all in my calculator, I should get about the same answer. It won't be exactly because we had to round it, but you should get about the same answer. So that's another way of doing it. Since you know probability being higher than B, you can just do inverse normal of that. Again, since I have an old calculator, I got to use the left side, so I do 1 minus that. By the way, if you're on, you can always just do this. This works. For the lazy. Right, just let the calculator do it for you. My mean is 21, and my standard deviation is 3.21. Hit enter, about 16.56. Hey, see? Exactly around to 36 figs. So 2 ways to do it. One way is, again, the normal distribution graph is symmetrical. So the distance from here should be the same distance from here, since they're the same area. They cover the same area. So you just figure out the symmetry behind that. Or do the way we've been doing it, inverse normal. Number 8, I think it's the last one. Yeah, yes it is, just making sure. Let's go there. A box contains a large number of biscuits. The weight of bits are normally distributed with a mean of 7 and a standard deviation of 0.5. So here's my mean. Here's my standard deviation. One biscuit is chosen at random from the box. Find probably that it has that this biscuit weighs less than 8 grams. So we're just gonna draw it. Here's 7. I'm gonna be less than 8. So all that. So we're going to go from E99, negative E99 to 8, mean and standard deviation. Right, again, they want us to find the probability. So this is a normal CDF problem. We're going from left to right. So negative E99 to that. So we bring out our calculator and just do that all over again. Second distribution, normal CDF, negative E99 to 8. My mean is 7. And my standard deviation is 0.5. And we get 366.977. There we go. B, between 6 and 8. So here is 7, 6, and 8. Again, I want to make them about symmetrical because they're exactly one apart from each other. Doesn't be perfect, but you don't want to be like crazy lopsided. So between 6 and 8. So mine's a little lopsided. I actually don't like that. But we'll move on. So second distribution, again, we're just finding probability, so normal CDF. 6 to 8, everything else stays the same. 3 sig figs, I get about 0.954. So there we go. 5% of biscuits weighed less than D grams. Copy and complete the following normal distribution diagram to present information by indicating with D shade the appropriate region. So 5% of biscuits weighed less than D grams. Now remember the way it goes? Less than you start on the left hand side. We're going to start over here. We're going to go 5%. So 5% is not much. I'm just going to go like right there. And that's 0.05. And then this would be my D. Right again. So 5%. Less than start on the left side. If it's a greater than, you start on the right side. So we have that. Find the value of D. Well, it's going to be inverse normal. It's the left hand side, so it works out for me. My mean standard deviation are the same, so it's 7 and 0.5. So put that in our calculator. Second distribution, inverse normal, 0.05, 7 and 0.5. And I get approximately 6.18. So there we go. The weight of biscuits in another box would normally distribute the mean of mu and a standard deviation of 0.5. It is known that 70% of the biscuits in the second box weigh less than 5 grams. Find the value of u. So again, they throw us a little curveball here, but it's another, you're missing the norm. You're missing the mean in this case. So your mean is missing. So we have to use our formula. Anytime you're missing either mean or standard deviation, you use the standard normal formula. Standard deviation is 0.5. This is an important part. You gotta know how to rewrite that. It is known that 20% of biscuits weigh less than 5 grams. So they're saying the probability that x is less than 5 is 20%. Like that. So this is user formula. Plug in what we know. My x is 5. My standard deviation is 0.5. We always find z the exact same way. That's inverse normal. But their mean and standard deviation is 1, right? Z is always the same thing. You always find z the same way. It's always inverse normal, 0, 1. What's my area? Now it's less than 0.2. So again, you could draw it. In this case, I know though, right? Start on the left side, so 0.2. Like that. So it's on the left side, so we're good to go. So let's plug this into our calculator. So second distribution, inverse normal, 0.201. So negative 0.841612. Negative. Remember, since it's I don't have an answer yet. Like there's not an answer to this question. I don't round it to the very end. So that's what my z is. So let's rewrite that all together. The problem. So I get negative 0.84162 is equal to 5 minus mu over 0.5. So it's just a math problem. Let's multiply both sides by 0.5. So this cancels, that cancels. In my calculator, so multiply that by 0.5. So I get that. Negative 0.4208 equals 5 minus mu. And again, if you know me, I like to add mu to both sides. Subtract 0.402. It's already negative actually, so add 0.4. There's a negative, so add 0.4208 to both sides. So we get mu equals, in this case it's already negative, so I guess I can multiply by negative, then add it to 5. So 5.420813 figs, mu equals 5.42. And there you go. That's the worksheet.